Hi, everybody, and welcome to lesson 4-5. We got two goals today. Our first one is that we're going to be able to write a function rule that represents a mathematical sentence. And our second goal is that we can write a function rule to represent a real life situation. So we're going to start off with this first goal. I'm going to give you two sentences. They look like this. And you can see it's a lot like what we were doing with expressions, where we're just going to take each of the words and change it into a mathematical symbol. So let's give this a try. Okay, our first one here says P is 9 less than half of Q. When you see this P is, we know that is means equals. Like 3 plus 5 is 8. It's equal. So I can just change this to P equals. Then we got a couple different things going on here. We've got 9 less than, and we also have half of Q. Now, half of Q can be written a couple different ways. I could write half of Q as taking Q and dividing it by 2. That would give me half of Q. But I could also write this as 1/2 times Q, because of means time. So half times Q would be half of Q. Either one of these would really be correct. I'm actually going to pick the half times Q. So I've got half of means multiply and Q. Then we'll see 9 less than. Just looking at the words less than, that's subtraction, and less than is a turnaround word. It's actually going to be written after or on the back. So take away 9 at the back, because imagine if it said 9 less than your age, you'd take whatever your age is and then minus 9 after it. So here we have P is 9 less than half of Q, and that is our function or equation. Let's try the next one. 7 more than the quotient of a number and 4 is 10. So here where you see is 10, that's equals 10. Then we got a couple other things going on here. 7 more than, and we have the quotient of a number and 4. We know that quotient means to divide, and wherever you see the word and, that's where you put that. So if we have quotient of a number and 4, we have n divided by 4. More than means to add. If we want 7 more than this, we have to add 7 onto it. Because addition is commutative, I could have these two in either order, doesn't really matter. Okay, so I've got 7 more than the quotient of a number and 4 is or equals 10. And then that would be my function or my equation for that sentence. So it looks like sentences went pretty well. Let's move on now to our second goal. I'm going to be giving you some real life situations, and we need to be able to write a function rule to represent them. So we're going to see a problem about an archery club. We're going to see a problem about a road trip. We'll see, oh, this one's going to be kind of fun. This one's more geometrical. And then we've got one about a bottlenose whale, and we have one about baking. And lastly, this is going to, on problem number 6, you're going to kind of see some multi-step things we're going to need to do to build our equation. Okay? And then hopefully all of that will then, after all of that, you'll be able to kind of say, yeah, I think I can do these two goals. I think I can write a function rule for sentences and real life situations. Okay, so we're going to come back to that. All right, before we actually get started on example number 1, I want you to be thinking about when we were writing equations for tables and how this is going to relate to what we're doing today. Okay, so before, when I gave you a table like this and I asked you to come up with a function rule, you wrote, well, to get y, I would take something times x and then either add or subtract. And now that number that you multiply by x, that's your multiplier. And so you would look, to quickly find that. Remember how we talked about how you could look at this pattern, and in this pattern's going the pattern in the y over the x. And if this is up 4, up 1, then that's a tiny 4. Then this would be 4 over 1, which is 4. That's our multiplier. Okay, and then once you figured out what you multiply by, then you have to figure out what do I need to add still to that. So if I multiply this x by 4, I would get 0. What do I still need to do? Well, I'd need to add 5. If I multiply this x by 4, I would get 4, and then I still need to add 5. If I multiply this x by 4, I would get 8, and then I still need to add 5. So I want you to be thinking about this for just a moment. When I take each of these X values and multiply them by 4, it constantly changes. This amount changes, doesn't it? Here I have a 0, here I have a 4, here I have an 8. That's going to change. But what always remains constant is the number that you're adding or subtracting. So I'm adding 5 here, I'm adding 5 here, I'm adding 5 here. That's my constant. That does not change. But this amount, my multiplier, this amount, when I multiply 4 by X, that's going to change every single time. And we saw that happening. Okay, so keep in mind when we're writing function rules, we have a multiplier, which is going to be our changing amount. And then this number we're adding or subtracting, that's going to be our constant. That does not change. Okay, let's start with example number 1. Here's problem number 1. We have an archery club that charges an annual membership fee of $65 plus $2 per visit. We want to write a function rule for the total cost of belonging to the club if you make any number of visits in a year. So this is what we're trying to do. We're writing a function rule for the total cost of belonging to the club. Well, one way of doing this is you could always write a table here. And I know that you guys know how to write a function rule from a table, so you could always start off that way. So if I don't make any visits to the archery club, I would pay $65 and then $2 for every single visit I make. So if I make one visit, it's going to go up $2. So I'd pay $67 for that year. If I went 2 times, I'd pay $69 that year. If I went 3 times, I'd pay 71. So from this table, I could then write my function rule, doing what we've done before, like back in lesson 4 too, okay? But we don't need to have a table in order to do this, because think about what we know about writing function rules, right? Let's kind of keep this in the back of our mind. So we've got 2 things going on here. We have an annual membership fee of $65. That's never going to change. And we have the fact that we're paying $2 per visit, okay? Now, we want to figure out our total cost of belonging to the club. So I could say T is going to be my total cost. Whatever I multiply by here, this is my changing value. So the cost of belonging to the club after V visits, I'm going to multiply the cost of each visit by V. So that's $2 per visit. Then I'm going to be adding that constant amount that doesn't ever change. That's that $65 membership fee. So that $65 is going to go right in here. So then I end up with total cost being 2 times my number of visits. That's going to be changing depending on how many visits I make, plus the $65 that I pay for the one-time payment. That membership fee will always be $65. Okay, so there's my function rule. Now for this next part, it says, how much would it cost if you use the club 15 times? So we make 15 visits to the club. So the total cost will be $2 times 15 visits. I'm just plugging in 15 for V, adding the $65 membership charge, and then I just simply use the calculator to find the total value. 30 plus 65 is $95. Okay, so I'm using my function rule to plug in a value for V for visits. All right, so there's example number 1. Here's problem number 2, the road trip. To prepare for an upcoming road trip, you fill your 19-gallon gas tank. You estimate that your SUV will use about 3 gallons per hour. So write an equation that will tell the amount of gasoline remaining after any number of hours. That's our goal. So what important things do we have here? We fill a 19-gallon gas tank. So that 19-gallon gas tank isn't going to change. It's always going to be 19 gallons. But we're going to be using or subtracting 3 gallons every single hour, per hour. That per tells us right there that that's our multiplier, right? So I could set this up as a table and write the equation from there. Think about if this were a table. At time of 0, if I didn't drive any hours, I'd still have 19 gallons in my gas tank. But if I drove for 1 hour, I'm going to have to subtract 3 gallons. If I drove for 2 hours, subtract another 3 gallons, and then another 3 gallons. So I could use this table to write a function rule like we did in lesson 4 too. If a table's helpful for you. If you're stuck, you can always resort to a table. Otherwise, let's go ahead and write our function rule. So remember our rule, y equals box x plus box. Kind of be thinking about that as you're writing your rule, okay? So amount of gasoline remaining in our tank. Gasoline equals, so instead of y, I'm writing the amount of gasoline, right? Because if we look over here at the table, here's x, here's y. Gas is our y, isn't it? Okay, so gasoline. Then How is this changing? What's the multiplier? 3 gallons per hour. So per times hours, right? How is it changing? We're using 3 gallons per hour. So that can be a positive 3 or a negative 3. A negative 3 because we're using it. And then plus our constant. What's constant? What's not changing? Well, that's our 19-gallon gas tank. Oop, I need purple. 19-gallon gas tank. Okay. So I'm using $3 each hour. So this is going to change. Every time I plug in a different value for hours, this is going to be changing. But the 19-gallon gas tank, that 19, that's not ever going to change. Okay, so if I were to plug in, how much gas would I have after 10 hours? I would take -3. Well, I really wouldn't have that much. I wouldn't have enough gas for that to happen. But if I plugged in 2 hours, I could see how much I would have. If I plugged in 2 hours here, I would end up with -6 plus 19, which is 13 gallons of gas, which is exactly what my table says over here. Okay, so here's my function rule. There's number 2. I told you to get excited for number 3 here. Pay close attention to 3 because you're going to see a problem like this on your practice that's kind of tricky. Write a function rule for the area of a rectangle. Okay, remember with area of a rectangle, that's area equals width times length or length times width. But what specifically about this rectangle do they want us to write an area or an area formula for? So it says whose length is 3 inches more than the width. So important thing there, the length is 3 inches more than the width. We're going to get to that second part of the question in a minute. Let's just write the rule. So we know that area of a rectangle is width times length. Now, if we're writing a function rule, we can only have 2 variables, two letters in it, as in all the function rules you've written, right? With the y equals something x, right? Y and x. So I have to pick 2 variables. If I'm writing the formula for area, I have to have the a for area, but then I can only have a w or an l. So let's take a look at the rectangle I have here. Let's write down what we know. It says the length is 3 inches more than the width. So if I were to take that length is, I could say length is equals 3 more than the width. 3, what symbol means more than? Plus, and then the width, right? So I could take the length and write it as the expression 3 plus w, right? Just right there. Sorry, just right there. And what expression could I use for just the width itself? Well, just a w, right? So the width is w, and then the length is 3 more than w because of what it said there where I underlined in red. Okay, so now if we're going to write this as a function rule, I'm going to put the times sign right here. I want width times length. So let's just say that here's my width, right? So I'm going to put w. And then if this right here is my length expression, I could put w plus 3 right here. But I want to show that I'm taking the width and multiplying it by the entire length, so I'd want parentheses there. So here's my width times my length, okay? Now I could simplify this, absolutely. If I did that, I would just use the distributive property, and I could really say a equals w times w is w squared plus w times 3 is 3w. And this would be my simplified equation for area of this particular rectangle. Okay, but note that this is still okay. This is not a bad thing. This is still correct. We just kind of got rid of the parentheses with the distributive property. Okay, now we're ready for the second part. It says, what is the area of the rectangle if the width is 7? So everywhere I see width in my equation, I'm going to change it to a 7 and figure out the area. So this is going to be 7 squared plus 3 times 7. This is 49 plus 21. And then when I add those together, I get 70. I can't add today. I get 70. So area would be 70, and then that looks like it's inches squared because it's area. So area is 70. All right. Now, if you go back over here to the picture, we can check that. If the width is 7, if I made this a 7 and 3 plus 7 would be 10. This would be a 10 by 7 rectangle, and the area would be length times width, which would make it 70. So my equation here actually works. All right, so that's how you do this one. Remember, if you get stuck on the homework, you can always come back and watch this in the lesson video. Okay, and then I've got problem number 4 here. From an elevation of -20 meters relative to the surface of the water, a bottlenose whale dives. Let me just give you an idea what's happening here. So if this is the surface of the water, this is 0, okay? The bottlenose whale is down here at negative 20 meters, all right? So that's what that means relative to the surface. The bottlenose whale is going to dive at a rate of 108 meters per minute. So this guy is going to dive. So I can kind of draw, if this is a minute, that's 108 meters, another 108, another 108, another 108. Every single minute, he's going down 108 meters, okay? So that's kind of what's happening. So we're asked to write a rule that gives the whale's depth as a function of time. So how can we figure out the depth of the whale for any given amount of time? Okay, so depth of the whale. Remember, keep in mind y equals box x plus box. Okay, keep that in the back of your head. So depth equals, instead of y, we're going to say depth of the whale equals what? Okay. So our multiplier, what's constantly changing? Well, if you look in the problem, it says the whale dives at a rate of 108 meters per minute. There's that per again that signals multiplication. This is the change. It's a constant change, 108 meters per minute. So 108 meters per minute. Now I'm going to maybe change this to m for minute instead of having an x, okay? But it's diving. So I need to ask myself, you guys, is this a positive 108 or a negative 108? And it would be a negative 108 because the whale's diving. It's going down 108, down 108, down 108 every single minute. Okay, I know that's kind of small. Hopefully you can read that. Okay, and then what's the constant? What's the amount that does not change? That's where you started here. That's the negative 20 meters. That doesn't change. That's where the whale starts. So that minus 20 is the starting point. So here we have our function. D equals negative 108 meters per minute minus 20, and that's the meters that the whale started at. So here's the function rule right here. Okay. Now it says, what's the whale's depth after 4 minutes? All right, so I'm going to plug 4 right in here for minutes and figure out where the whale is. So the depth is negative 108. He does that 4 times, right? 4 minutes. He's going to dive down minus 108, and he starts at minus 20, negative 20. So I'm just going to use the calculator for this and type this in right here to the calculator. So I got negative 108 times 4, and I want a minus 20. And that's just going to give me negative 452. And that's the depth that the whale is going to be at, a negative 452, and this is meters. So that's below the surface. That's where the whale will end up being after 4 minutes here. All right, so that will be problem number 4. Here's 5. Getting back maybe a little easier. Here we have a little bottle of vanilla. You may recognize that if you do any baking. It holds 48 teaspoons of vanilla. The amount of vanilla remaining in the bottle decreases by 2 teaspoons per batch of cookies. Big batches of cookies, I bet. Write a function rule to represent the situation. All right, so we want to figure out the amount of vanilla remaining, okay? So the amount remaining, I can just say amount of vanilla equals what? All right, so what's changing? It says it's decreasing 2 teaspoons per batch. So they want us to use B for batch. So this is the multiplier. This is the change right here. It's decreasing 2 teaspoons per batch. And then what's the thing that's not changing? Well, that would be the 48 teaspoons, right? That's where it starts at positive 48. It starts. And that's how much is in the bottle of vanilla before we use any, is just the 48 teaspoons, okay? And then the change here, this is our multiplier, 2 teaspoons per batch. Per, again, means to multiply, right? So it's going to decrease minus 2 teaspoons per batch. And we start at 48, right? So let's try the second part. How much vanilla remains after 5 batches of cookies? So we're going to plug in 5 for batches. So the amount of vanilla remaining will be minus 2 that we use. We're taking away 2 5 times because there's 5 batches. That's negative 10, but we still have to add the 48 because that's where we started. So if I add 48, I would then have the amount of vanilla. It would be 38 teaspoons. That's how much would be left after I made 5 batches, because each batch took away 2 teaspoons, which took away a total of 10. Okay, so we got that one. Now we're ready for number 6. And I told you this is going to be a two-parter. This is going to be an interesting one. So here we got general admission tickets to the fair cost $9.50 per person. There's that per, there's that multiplier again. All-day ride passes, you're buying those too. That's $12.50 again per person. And then it says you're also going to need to pay for parking. So it looks like 3 things we're paying for when we go to the fair. So we're asked to write a function for the cost of going to the fair on Saturday evening at 6 p.m. Why would the Saturday evening at 6 p.m. be important? Well, because we're going to have to use this sign to figure out the parking. It didn't tell us how much parking was. So if I go on the weekend after 4, it would cost $10. So my parking is actually $10 fee. Okay, so that's how I figured that out. All right, so let's start with our function here. Cost of our function for the cost of going to the fair. The cost will equal. All right, so what am I paying for here? $9.50 per person. So this is my multiplier. This is going to change depending on how many people come. So I have $9.50 times X. But and X is the number of people. We'll just say it's X, okay? But then I also have to pay $12.50 per person again, because that's a per person fee for the all-day ride passes. The fare, just the admission to the fair and the ride passes is per person. All right, then I pay for parking. Now, parking doesn't change. It's always just going to be $10 for the whole car full of people. So that's that constant, right? That's that plus 10. Now, do you see here how these two could actually be combined together? They're both X's. They both are changing and they both are like terms. So I could add those two together. So if I add those two together, I'm going to end up getting 22. So really I could write this as $22 per person plus the $10 parking fee, because $9.50 plus $12.50 is 22. So this is my simplified equation. And again, I'm using X to represent, X is representing the people. All right. So now it says, how much will it cost for a 6-person family to attend the fair? 6 person. I can now plug in 6 people into my function. The cost will be $22 per person. So I multiply it by 6 plus the $10 parking fee for all of us to fit in the van, right? So then I'm just going to simply use the calculator, and I can take 22 times 6 and add the 10 and get a cost of $142. So the cost is $142 for all of these people to go to the fair. All right. So now let's kind of go back to our goals. We want to be able to write a function rule for a sentence and write a function rule for a real life situation. I'm hoping that you feel like you could do both of those things. Okay, so now your practice is going to be lesson 4 or 5, the practice assignment on Schoology, and there's a couple optional activities that are kind of fun that you can try, a quizzes and a Quizlet, and then you guys can take a screenshot of whichever one or both that you decide to do and email it to me so I can see that you went above and beyond and did some extra practice. All right, thank you for joining me for lesson 4 or 5. Have a great day.